Hello. My name is Martin of ABES in Austria. This is yet another video clip of our series of videos explaining various aspects concerning our geometry control software. We have ABES geoCon in front of us, and in this installment I would like to hone in on the translation rotation inputs when setting out casting for a new matchcast segment. Just as a quick reminder, this is our input screen driving the input for the setting out of a new segment. We have the control point data here for the matchcast segment, and we have the control point data in this table down here for the conjugate segment. We have input options up here titled crossfold rotation and translation, and it's these inputs in this area of the screen that I would like to discuss in the following. This is the example I will be using in the following. We have a base segment here that's already cast, it's shown in green, and we have a new segment to be added in blue. The segment name is RHS P56S2, and if we look at the list here, the base segment is already in an S-cast state, and the S2 segment is in the setting out state. So this is what we will be looking at. Maybe what I would like to point out before we start is the fact that the cross-section system is quite a ways above the top of the cross-section, and the origins are placed at the point where the road alignment pierces the cross-section plane. So there is quite a gap here, which is a bit more than I'm used to, but that's good for visualization. And what I'd also like to point out is the fact that we have quite a pronounced crossfall here. So what we have is an offset downwards, and we have a crossfall for the two segments. Looking at the casting yard setup, we use this button to get there. We note that we've 10 different casting machines set up, and we will be using this casting machine down here for the purpose of casting our segment. Let's zoom in on that. And we already see what the default will be if we ignore translation and rotation input as shown just a couple of minutes ago. For the default setting, the program will simply take the segments as they are placed on the bridge and shift them as a rigid body shift, if you like, into the casting yard for casting, and it will provide the setting out data for whatever geometry occurs when you do that rigid body shift. And we see already what happens. The bridge segment is at a crossfall, and what we also see is the blue line here is the top of the casting machine, of the casting bed, and we are quite a ways down. The reason being the program will align the cross-section origin or the piercing point of the road alignment with the bulkhead origin. The origin of the bulkhead usually being the top of the bulkhead. So in our case, because the alignment is quite a ways above the concrete surface, the segment ends up below the casting bed, and because there is a crossfall, it's also tilted to one side. Not a very easy cast, I would presume. So let's turn to the rotation, crossfall rotation input first. It's inactive at this point, and we can switch to by control point input. And this opens up this field here and this field here. We can determine a horizontal line by choosing two control points on the cross section, forming that horizontal. And by picking control point A out of our list and B, the one on the left and the one to the right of the center, we ask the program to use the line connecting A and B, which is the surface of the concrete, to become a perfectly horizontal surface for casting. Let's accept that, and we already see what's happening to our cross-section. The cross-section has now turned, and the concrete surface here has become a perfectly horizontal surface in our casting machine. That's already half the battle won. However, we still have the bulkhead top up here and the concrete top down here, which is a function of the way we have defined this cross-section early on in geodesic. And of course, it will be practicable to match the concrete surface of our segment with the top, the blue line, the top of the bulkhead. And we do so by telling the program to move control point C up to the top of the bulkhead, to the origin of the bulkhead as it is. That's easily done with the translation input here. We switch to by control point. We select control point C to match the origin of our bulkhead, accept that, and lo and behold, our cross-section has now moved up in a horizontal top surface position and matching the top of our bulkhead. Looking at this in 3D shows the situation. We have our base segment out here, and we're setting out our first match cast segment in here. And if we switch off the visualization for the segments and switch on the visualization for the casting bed in green, we can see that now the top of our casting bed matches the top of the segment we are about to cast. Going back to the input, we can see that the coordinates have changed now, and the Z coordinates are all at 0, which is 0 is the top of the bulkhead. To be clear, the inputs for translation and rotation do not change the shape of the segment. We can have any inputs up here, and we can have any situations in the casting yard as we wish. As long as we follow the setting out data, and as long as we cast the segment as provided by the data from geoCon, the segment geometry will be as planned. The inputs for crossfall rotation and translation only influence the placement of the segment in the casting machine. And of course, it's practical to use these inputs when a situation like the one described here with a crossfall and an offset occurs. There is one more feature I would like to remind users in this context. These control points have been put in prior to the casting yard module geoCon, and sometimes the need arises to add control points on short notice, and this can be accomplished by using this button up here, additional control points. right click, insert a row. The control point gets a name. I call it BHM01. I'm linking the control point to the bulkhead. It's linked to the bulkhead. I'm giving it 0.5 meter in the x direction, and x being in the direction of the segment. Nothing, no lateral offset and no z offset. And I'm measuring these coordinates from control point A. We don't need to. We can use just raw coordinates, or we can link it to an existing control point. So our new control point, PHM01, will be located 0.5 meter in the direction of the segment center line X and away 0.5 meter from existing control point A on the bulkhead side. We already see the control point has been added to our list. It's linked to control point A. That's 0.5 meter. And if we confirm this, we already see the visualization in here. This is our new control point. So this is just an example to show how to add a new control point if necessary. For example, to input practical data for the translation and rotation piece. This concludes this video, and I wish you all good luck with the application of these inputs in geoCon.